So this workshop covers solving rational equations. A rational equation is an equation where you have rational expressions or fractions. So here we have x plus 3 in the denominator. Sometimes rational equations look intimidating, but they're really not so bad. The hard part is fractions, but the great thing is that it's really easy to eliminate all the fractions from the equation. We'll start with this. This is 4 divided by x plus 3. The opposite of dividing by x plus 3 is multiplying by x plus 3. So I'm going to take every term in the equation and multiply by x plus 3. And we have to do this to every term because we're multiplying both sides of the equation, which means multiplying every single term in the equation. And remember, it's x plus 3 over 1, so we're not going to change the denominators, right? Only have to multiply the numerators. So in this first one, x plus 3 divided by x plus 3, that cancels, divides to 1. Here we're just going to have, so this gives us 4 plus. This I will just leave as 5 times x plus 3 for now, over 6 equals 23 times x plus 3 over 18. Now this is still annoying because I have denominators of 18 and 6 here, but just like I eliminated x plus 3 from the equation, I'm going to eliminate 18 and 6. So I multiply everything by 18, because in fact 18 is just 6 times 3. So multiply this by 18. 18 times 4 is 72. And here, 18 divided by 6 is 3. So this is really times 6 times 3. And the 6 is canceled. So we're left with 5 times 3, which is 15 times x plus 3 equals, and here, 18 and 18 divide to 1, so we have 23 times x plus 3. At this point, it's a simple equation. We don't have any denominators, we just have a one-variable linear equation. So 15x plus 45 equals 23x plus 69. And if we gather up all the numerical terms on one side and the variables on the other side, we'll end up with 8x equals 48 and x equals 6. So, the only thing that's new is multiplying by the denominator. So this was a simple example because we ended up with a one-variable linear equation. Sometimes rational equations can get a little bit more tedious and require some more trickery, but the same concept is going to apply. You want to eliminate denominators. So we take this example. 2x over x plus 5 minus x squared minus x minus 10 over x squared plus 8x plus 15 equals 3 over x plus 3. Now, one way to do this looks really, really, really disgusting. Because you don't want to multiply every single term by this, this, and this. But one thing we can do to help us is if we factor this, so we know x squared plus 8x plus 15, we have a product of 15 and a sum of 8. So that factors to x plus 5 times x plus 3. And suddenly our lives just got a lot easier. If I multiply by this denominator on all 3 terms, then, watch, so times x plus 5 and x plus 3. Here we have a pair of x plus 5's divide to 1, so we're left with 2x times x plus 3 minus On this one, when we multiply by the denominator, the whole thing divides to 1. So we're just left with the numerator. Divides to 1. So we're left with x squared minus x minus 10. Now careful here. Minus the whole thing, x squared minus x minus 10 equals, we multiply this one by x plus 3 and x plus 5. And a pair of x plus 3's divides to 1, and we get 3 times x plus 5. At this point, we have, in fact, reduced the equation to something we know how to solve already. It's just kind of messy looking. So first, I'm going to expand all of this. So this is 2x squared plus 6x. Here I'm going to distribute my negative 1 and get minus x squared plus x plus 10 equals 3x plus 15. Remember, this is a negative 1 that's being distributed to all three terms. So just change the sign. Now I'll combine all the like terms. I have 2x squared minus x squared is 1x squared. 6x plus x is 7x. And plus 10 equals 3x plus 15. Now what type of equation do we have? You yelled quadratic at the screen, right? Good. What do we do with a quadratic equation? You yelled set it to 0, right? Right, you did. Subtract 3x and subtract 15 from both sides. And we get x squared plus 4x minus 5 equals 0. And this equation can be solved by factoring. We need numbers that multiply to make negative 5 and add to make 4. Go ahead, yell them at the screen. I can hear you. X plus 5 and x minus 1. 5 times negative 1 is negative 5. 5 plus negative 1 is positive 4. Which means our solutions are x equals negative 5 and x equals 1. But wait, we could have extraneous solutions. And the only time with rational equations that you'll end up with extraneous solutions is if one of these solutions and it makes you divide by 0. And we can see if I were to plug in x equals negative 5 into x plus 5, then I'm going to have a 0 denominator. So x equals negative 5 is in fact extraneous, and x equals 1 is the only solution. All right, so we did a simple example and a hard example. Really, all of the examples of these problems fall into something that looks like this. So practice.